All right, guys, welcome back. Um, in the first video on hash tables, we just went over basic implementation for what a hash table is, how to get set up, setting and getting. Um, I hinted at the fact that there's going to be some problems with collisions, and we need to be able to handle those. In the second video, I talked about one way to handle collisions, which was implementing each item in the array as a linked list with nodes storing the information. And you can traverse those linked lists to access information. This is all sort of presuming that the indexes or that arrays are of constant size. Obviously in JavaScript that's not really the case. Well, it doesn't look like the case to people. Under the hood, I'm fairly certain that pop and push and shift and unshift are just destroying and recreating the arrays for the purposes of those methods. Other languages, like I know Rust, for example, and I think other languages of similar ilk, um, arrays are of constant size. So this problem's a bit more tractable in those situations where you have arrays and you can't necessarily resize them as easily, or you can, but they're just as easy as the methods that we're doing today. So linked list was one option. The other option is just to resize the entire array. And the major drawback to that is that it's going to take a bunch of time to insert. Could take a lot of time to insert. But the flip side of that is that you're going to maintain a guaranteed O of 1 search time. So if you need really quick searches and you don't care how long it takes to insert information, this method is actually probably superior to any other method. But as we'll see today, we do have a collision with the properties that we have set up. And that collision does cause us significant problems. So, well, it doesn't cause us significant. It forces us to resize a few times to handle that. So let's go ahead and get started. So this is what our first hash table looked like, right? We just store the values and we just return them. In the second one, we had, which is what we're going to do today, we stored things as key value pairs. In this, right here, instead of storing them as an array, we stored them as nodes, and we had to call functions on the getting and setting, which were we had to call methods on our linked list class or constructor. We're going to store things as arrays today. There's no point in creating a special linked list with nodes because there's only what we're trying to do is maintain only one item, in this case one array, at each index. We are going to need a function. It's just giving me an error. Resize. That is interesting. Oh, it's not that interesting. And actually. No. So we need to make sure that once we're done resizing, that we're going to need to recompute the index because the index is working off the table dot length, and we've got a new table length. So we need to recompute the index. If that index also has a collision problem, then we need to go through the whole process again. So this dot resize, and then we say idx equals this, because the table will have been reset at this point. Okay. So we've now changed our setting function. So let's go through. This is our hash. We went that first video, second video, we saw that. Right here, we're checking to see if there's already an item at that spot in the index. If there is, then we're going to go through the process of resizing it. And then we're going to go through the process of resetting our index for the value that we're trying to insert. Then we're going to go back and check to see if the new index that we have is taken up. And if it is, we need to resize again because we didn't do it right the first time. Well, we did it right the first time. It just didn't work. And then we're going to keep on going through until we produce an index that works for us. So let's go through and see what this resizing is going to look like. This length. Oh wait, this is not a function. For that I equals 0, I is less than this table dot plus. And then we're checking if equal. So if there's an item there, we're going to need to go through basically the same process that we go through in a setting function. So const ex equals hash string, and we are passing in this dot table dot that is our key, because remember we are storing things as an array of key value now, and we should pass in the length of the new table. We also need to worry about collisions here. So if there's nothing at new table index, you can go ahead and set equals see. Actually, let's use this operator here. If it doesn't, so if it is taken up by something, we actually need to go through this whole process again. So yeah. So we're going to tick up N if we encounter a collision here. I don't know if so. We're going to implement a label. I think labels can only be attached to ifs, fors, and whiles, and similar ilk. I don't know if I can just stick it anywhere. If I could stick it anywhere, I wouldn't have to implement a while loop here. But as it stands, I think I do. Under there. Cool. False. True. Continue. Okay, so what have we done here? We have implemented what is called a label. Labels, and so there are going to be cases where you have nested loops, as we do here, and sometimes you want to break out of the inner loop and go right back around to the outer loop. In those cases, the most straightforward way that I know how to do it, and I think it's the most straightforward way to do it, is to implement a label. If we just put continue here without a label, it would go up to this and tick up I probably. But since we said continue and then we pointed where we wanted to go, it's actually going to go here, and we're going to exit this for loop without finishing it. But not before ticking up N, so that when we recompute the new table, it's going to be of a different size, so that when we go down here, hopefully we won't run into a collision. And we can check to see if we get a collision here. I don't know that we will. We're probably going to get a resize. So we want this to table equals new tab, break for good measure. Okay, so we got that. We're returning correctly. Let's go ahead and yeah, we resized a few times there. Look at that, 111 empty items, 223 empty items. 200, yeah, so it looks like we resized. So we resized right here. We never resized down here, which is that's incredible. I wonder if we had to resize only on the same thing. There's a so they were all different instances of having to resize. So it wasn't like we ever ran into a problem where we resized and we still had a collision problem on the same instance of trying to set. It was all different instances of setting that we ran into the issue. I believe. Oh no, you know what? Yeah, the loop's not going up there. Um, that answers my question whether or not you can put a label anywhere. You can't. Um, yeah, we're not getting 3 at any point, so it doesn't look like we're ever get. Yeah, we're definitely not getting caught here. Um, oh, this is not where we need to put to check it. Um, this is where we go. So let's see. Log and let's console.log the key. Yeah, it's all the same value. It's the last value, and it's colliding with I don't know, but it's colliding with something over and over again. Maybe it's different each time. Might be the same. I imagine it's probably the same. Um, but you can see it's never getting caught up in this part. It's getting caught up in this part. Um, so, but we have properly set everything. I think we've got prop A, B, and C and D. This is prop D, prop C, prop B, prop A, and we have colors A through E. Actually, I can just count out the values 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so um, we've got everything correct. Ton of extra space now, which is probably why you want to use prime numbers, because I think collision is less likely to happen with prime numbers. Um, probably also want um, property names that are a little bit different. These are all pretty uniform. um, but that's how you resize. Resizing is going to be slow, like I said, for insertion, um, because you're going to run into this issue. But it is going to, if you're absolutely concerned with the searching and finding after it's been implemented, I mean, this is going to be the best way to do it. A linked list is going to add a modicum of time. You can do a hybrid approach where you resize occasionally after. So you could say like, okay, 17. Once we have 80% of 17 items here, we're going to resize no matter what. And you can still have a linked list in there in case of collision. You're going to resize a lot less. You're going to have list nodes that are working off of each other probably. So you're going to sort of cutting the difference. The linked list is saving on insertion time by a huge factor compared to this. But it's slowing down your searching speed. This is going to have lightning fast search capabilities. It's not going to have great insertion speed. It's going to have terrible insertion speed. This is by far the worst way to have to insert something. But that's obviously at the expense of being able to find things very quickly. So, yeah, I mean, there's a way in which you just, you could say, load equals 0, and then you tick up the load. And then you say something like this: if this dot load divided by table length is greater than 0.8, then you resize then. And if you're going to do that, you're going to definitely need to put in a linked list, or keep everything as like, or just arrays where you're just pushing arrays onto each other. Because you're still going to have the chance of collision. All the resizing is doing is lowering the odds of collision happening and preserving some of the quickness of the of this method for searching. So just sort of splits the difference between the two. So I hope you guys found this informative. I sure as hell did when I was learning all this stuff. I think I'll start going into a bit more of a deep dive on the different kind of linked lists, binaries, singly linked, doubly linked, and we can take a look at those. But for now, as always, really appreciate you guys checking out the channel. Drop a comment, stuff you want to see, drop a like, hit the subscribe button. But other than that, I will see you guys later. Bye.